And let there be light. Ta-da! I'm here. Yes, I haven't disappeared. You just couldn't see me because I took away all of the light and I made it dark. And the darkness is the absence of light. And we need light in order to see, don't we? You're going to show what the racket is to everybody. This is the racket. He's probably fascinated by me because I'm in my high-vis jacket for some reason. I wonder why I'm in my high-vis jacket, hey? Do you want to play with our old bit of paper that we made, the Viking paper? You're going to write your Viking story. Yeah, you go and write your setting. Off you go. Remember fronting adverbials and expanding noun phrases. Make sure you got all your spelling rules, yeah? Okay. And when you've done that, draft, edit, redraft. So you're probably wondering why I'm in my high-vis jacket. Well, today we're going to be looking at reflection and what reflection is and how things reflect. Reflective surfaces is what we're going to be looking at. So to recap last lesson, we should know that light is what we need in order to see, because without light we have darkness, and it's the light rays that come from light sources like the sun, like this light, like that pendant light. Those rays, they hit objects and they bounce off them, and then the light bounces off those surfaces into our eyes, and our eyes can detect that light, and the brain and the optic nerve do some funny things in order for us to create an image of what that is. But the image that you're seeing is mostly the brain. It's that light that's reflecting off of things that is the crucial thing. So then you've got to think about why do things reflect? You think about this high-vis jacket here. Why does that reflect? It's got these panels here. I think I've got my phone. I'll show you the light on there. You can maybe see the reflectiveness of it. I know that on the back of it, it's got some reflective bits so that people can see me in the night. So when it's night, this light gets shined on it and it reflects the light. But what is actually happening there? What is the physics behind this part of science that we're doing? Is under the bracket of physics. So we're going to look at some reflective materials. Might be looking at short film soon, but we're going to be thinking about what does it look like, or what makes a reflective material work well. How does it reflect the light? What colours are best for reflection, and why are they useful? Remember, if this video doesn't work, I'll post a link onto it. Sometimes YouTube doesn't let me show videos because I don't have the rights for them, but let's see what happens. Turn the sound on.
If you're going to be out in the dark, it's a really good idea to wear clothes that reflect light well, so you can be seen easily. Different colours reflect different amounts of light, and the material a piece of clothing is made from may affect how light is reflected. The yellow jacket seems much brighter than the dark red one. You can see it more clearly because it reflects more light, but some materials can behave surprisingly. This grey jacket doesn't seem to reflect very much light. Even with the headlamp shining, it doesn't look very bright seen from this angle. But seen from a driver's point of view, the bands show up really well. That's because these bands are made out of a special material which reflects light in a particular way. Light from the headlights is scattered in all directions by the yellow jackets. But when the light from the headlamps reflects off the bands, it all reflects back down the same path, straight to the driver's eyes. Because more reflected light reaches the driver's eyes, it looks much brighter. The material the bands are made from is called retroreflective. The light from the car headlamps falls on the roadside, but from the roadside the effect isn't very special. But look at the view from inside the car. The signs look really bright. Nearly all the light from the car headlamps is reflected back off the side to the driver's eyes. That's because the signs are made from retroreflective material too. But even the best reflective gear doesn't work if there's no light source at all.
Dun, dun, dun. Interesting stuff there. So we're talking about these light rays, and we're talking about them being reflective. We're talking about them being bounced off different surfaces, and some surfaces work better than others at doing that, and some surfaces reflect the light in different ways. I'll hopefully try and explain some of the science as best I can behind it. It is very, very tricky stuff because we're talking about rays of light, we're talking about photons, things that we can't see with our own eyes, but we'll have a go. So light travels in straight lines. That's the first thing you have to realize, that the light that comes from the light source, that comes from the car headlights, or comes from your bulb or from the sun, it travels in a straight line, and when it hits an object, that light bounces off, and when that light that hits something bounces off something and hits our eyes, that's how we can see the object. However, you can make something seem brighter depending if you change the material. So if it can, the amount of light that it can reflect, the brighter it will appear. Hence why we use those shiny bits of material for reflective gear, and this yellow absorbs some of the ultraviolet as well and kind of illuminates whilst I'm sat here. But like they said at the end of the video, it all needs light in order to do that. And the thick bands of silver obviously were brighter because they could reflect some of the light more clearly. I'll explain that a bit better. I've got a bit of a better diagram. So the light from the torch hits an object and then it bounces off there. Remember, it's staying in straight lines. So it doesn't scatter, it stays in that straight line. And you'll learn all about the angles of lights and stuff later on, but we just need to know that light reflects off objects by coming from a light source, hitting an object and bouncing and reflecting off it. Some materials reflect the light really well. Some materials, mainly darker ones, don't reflect the light very well. They do something else. They absorb a lot of that light. And reflective gear can be really, really useful because it helps you see in the dark, helps people be easily seen at night, and they're useful to identify people like firefighters, builders who might work in dangerous places and need to be able to be seen quite quickly. Another place you see reflective gear is the cat's eyes in the middle of the road, or if you've seen road signs where it tells you where verges are. Those reflective pieces are really good for seeing where you're going. And a mirror is an example of reflection. A mirror is a really, really shiny surface that helps us see ourselves, but also lets us see what's behind us as well. But usually we use mirrors to look at ourselves, don't we? The light reflects from us off the mirror off this really shiny surface. And they're called retroreflectors, those really smooth surfaces that we can see the signs. Here's a bit of an idea that you could do: is design your own book bag to make it really reflective for those winter months. Where are you going to put your reflectors? Where make a bag that's really a safe bag for nighttime users when they're walking back in school in the dark. Do you just want 2 reflective strips there, or can you make it? What materials are you going to use to make a good reflective night bag, a high vis bag? And then there's a little bit of a science activity that you guys can do. I'm not sure how great it works, but I think if you guys have a go and let me know, because that's what we would do in the classroom. We test our ideas with an experiment and then report on our findings. If it works, great. If it doesn't work, we just report that back and try and change our experiment so we do get something that works. This is the protocol. This is the instructions to test how reflective something is. If the material you need a torch and some paper. I tried to use my phone torch, but it's hard to get paper around it, but I'm sure you guys got a bit more time, you can definitely have a go. And if the material reflects light well, you will see the reflective light shine through the white card and light it up. So the idea behind that is that you've got your torch and your paper, and if the object that you're shining on reflects a lot of light, then it will bounce back onto the paper, and the paper will get brighter. It'll look like it's getting more white, I guess. But you guys have a go with that yourself. And I'll put all these activity sheets in the Google Drive as well. So then you'll basically see which colours, why does this reflect really well, why do high-vis reflect really well, and why do other colours, like your dark hoodie, not reflect so well. And maybe you can think about that when you're going out at night and you're playing and it's dark, how you're going to be best seen by drivers or cyclists. So I'll just show you one other thing that kind of hopefully explains it a little bit better. So when you can see your reflection in the mirror, or you can see a reflection in the water, or the bands that are reflective, the light is hitting that surface, and because that surface is so smooth and shiny as well, the light rays stay in a straight line and they stay focused. That's why the signs look really bright from the driver's view, but from another view, they don't look like they're lighting up. It's because that reflected light hasn't had a chance to scatter and go off in different directions. It's staying in a focused trajectory, a line. So if you think that this is a water or if this is a mirror, you're going to get a very clear view. Imagine if the water is a bit bubbly, that light's going to get scattered in different directions, and it's going to make the reflection look a bit, not as clear. So those bands, if the material isn't smooth as well as shiny, the streaks aren't going to be as clear and as bright. So this yellow is good at illuminating in all directions, but because you can see it's ruffled, the light's getting scattered everywhere. These silver bands here that I've got, they're very smooth and also shiny, so the light that hits those doesn't get scattered and bounced in lots of directions. It stays in a straight line and goes directly to your eyes. Another science experiment you can do to show the effects of the light being bent is, bear with me a second. to get a spoon. Now, a spoon is like a mirror, isn't it? The first job you've got to do is make sure it's really shiny, because we know if it's dull, then it won't reflect the light. So give it a polish, just make sure it's nice and dry, because the water, if there's any water on it, that will also scatter the light. And if you look at it from the back side, you will hopefully see yourself, and as you move it around, you'll see that your face kind of stretches a bit, doesn't it? That curve in the spoon, and the light, because it's not flat and straight like here, when the light hits this part of the spoon, it bounces at a different angle than when it hits this part. So the image that's being reflected, the rays that are being reflected, are stretched. Hence why my face gets stretched. And if you turn it on the other side, you'll see that you actually become upside down. The light rays that come from the light source hit me, hit the spoon, and then come back again. The rays actually flip. A few experiments that you can do to show a bit of reflection. All you need to know is that the light that's coming from a light source in a straight line is hitting an object, and if it's nice and smooth, it will reflect the image back onto it. So when you look at an image, that isn't reflection, that's just your brain picking up the image. But if you can see that image in a mirror, that's because the shiny surface has reflected that light as well. Light rays, very complicated physics. But have a go at that activity, that experiment, and maybe try and look at designing some high-vis wear. It doesn't have to be a bag. You could design some clothing for workers, or cycling gear. If you like cycling, you want to do some night vision cycling gear, try and design your own high-vis gear. What materials would you use? Or if you want to just see which materials reflect lots of light, just do that. But that's enough for today. Have a go with those lessons. I'm not quite sure yet. I'll see what we're looking like, but there might be no videos on Monday as people just try and catch up with their writing, and they're given lots to do over the weekend. So don't do any work over the weekend. I will see you guys on Monday. Good job. Keep up the hard work. Have a great weekend. If you need anything, just let me know, and I'll try and get back to you as soon as I can. All the best, guys. Keep working hard. Bye-bye.